All right, so this is homework, uh, page 96 to 99. And we are beginning with non-calculator problems. So the directions say write the quadratic function in standard form. Standard means vertex form. So in general, we're going for y equals a times x minus h squared plus k. So our job is to find hk, and we just get a from the original equation. Whatever's in front of x squared is the a value. Sketch the graph, identify vertex, axis of symmetry, x-intercepts. You can graph to verify. So first off, I want to get the vertex. So I'm using the vertex formula. The vertex formula is where h equals the opposite of b over 2 times a. B is the number in front of the x term. A is the number in front of the x squared term. So h comes out to 3. And then you calculate k by finding f of 3. So plug 3 in. You get 9 minus 18, negative 9. So the vertex is 3, negative 9. And that tells me, actually, I'm not going to write that down. Oh, no, yeah, I am supposed to write that down. Sorry. The vertex is 3, negative 9. So that's one answer they wanted. The standard form or vertex form of the equation should be f of x equals, there's a 1 in front of the x squared, so I don't have to put anything in front of these parentheses, x minus h squared plus k. So this is the equation. The axis of symmetry is x equals 3, goes through the vertex. And find the x-intercepts. So now you could graph first, because if the x-intercepts are nice, then you don't have to worry about it, but I'll do both. So let's go ahead and graph the vertex. It's 3, negative 9. And then this is an x squared graph. So remember, you have this parent function memorized. You know, from the vertex, you go over 1, up 1 on both sides. From the vertex, you go over 2, up 4, because I'm thinking x squared. 2 squared is 4. 3 squared is 9. So this does have nice zeros or x-intercepts that you can get right from the graph. Looks like it's x equals 0 and 6. But if you weren't doing that to get the zeros, if you didn't want to do it off of graphing, you're setting your equation equal to 0, and you should be factoring. And I get the same answers that way too. So if you can get it from the graph, that's fine. I'm not going to require you to factor it, but I'm just showing you that you have options here. Okay, let me get some of this out of here. Okay, so number 15, h of x is x squared minus 8x plus 16. So again, let's start with the vertex. So h is the opposite of b over 2 times a, which is 4. K is h of 4. Plug 4 in, you get 16 minus 32 plus 16, which I believe comes out to 0. So the vertex is 4, 0. The vertex form equation would be h of x equals x minus 4 squared plus 0. There's nothing in front. The a value is 1 because there's just a 1 in front of the x squared. So there's standard form. Axis of symmetry is x equals 4. By the way, I didn't graph the axis of symmetry on this last one, but it's just this line that helps you flip points. You should be able to reflect points across the axis of symmetry to easily plot points on the parabola. What about zeros? The vertex is the 0, so or again, you could set this equal to 0 and factor it, and you only get one answer. So x equals 4 is the 0. So if I plot 4, 0, this is again an x squared graph. So the graph goes from the vertex over 1, up 1. When you go over 2, you square that, you go up 4. Over 3, up 9. Same thing on the other side. So you don't have to graph the axis of symmetry for me, but you can if you want to. All right, here's number 17. So number 17, let me just make sure I'm writing these down right. F of x equals x squared minus 6x plus 2. So again, let's go ahead and find the vertex. So h is the opposite of b over 2 times a, which is 3. Why don't I have any of these? Why didn't I do any with a number in front? I don't know. I guess because most in this section are not here. You know what? We're going to do, instead of 17, let's do 23. I'm making a change. 22, 23. So let me go ahead and do 22. Executive decision. Okay, 22 is f of x equals x squared plus 3x plus 1/4. That's our f of x. So the vertex is going to be the opposite of 3 over 2 times a, which is negative 3 over 2. We have to plug that in for k, f of negative 3 over 2. So you square negative 3 over 2, you get 9 over 4. 3 times negative 3 over 2 is minus 9 over 2, plus 1 over 4. This is 9 over 4 minus 18 over 4 plus 1 over 4, getting common denominators there. Negative 9 over 4 plus 1 over 4 is negative 8 over 4, which is negative 2. So the vertex is negative 3 over 2, negative 2. I can plot that. Negative 1.5 down 2. There's the vertex. The axis of symmetry is x equals negative 3 over 2. Vertex form, f of x would equal x plus 3 over 2 squared minus 2. Okay, and then what about zeros? Now, on this one, this isn't going to factor nicely, although maybe it does. You're setting an equation equal to 0. You could do quadratic formula, but that might be kind of terrible with a fraction. So what about this? I'm allowed to get rid of the fraction by multiplying both sides by 4. That would make this 4x squared plus 12x plus 1. Does that factor? No, but it at least saves me from working with fractions. So maybe I want to use this for my quadratic formula. You don't have to do that, but I think I'm going to like this. Opposite of b plus or minus square root of b squared minus 4 times a times c, all over 2 times a. Negative 12 plus or minus, this is 144 minus 16, so that's the square root of 120, is that 128? That seems right. Minus 10 is 134, minus 6, yeah, 128. Now 128 is the square root of 64 times the square root of 2. It's all over 8, by the way. So now it's negative 12 plus or minus 8 radical 2 over 8. And if these three terms can be divisible by a common factor, we need to do that. Divide everything by 4, so negative 3 plus or minus 2 radical 2 over 2. Am I going to figure out where those points are? No, they will just fall into line when I do my x squared graph. So the x squared graph, I can say, okay, over 1, up 1 on both sides. Over 2, up 1, 2, 3, 4. 4. Over 3, 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Same over here. Okay, and why did that just happen? Let's see if I can undo that. Nope. Okay. I don't know why my graph just shifted over just shifted over like that, but we will just ignore that. And honestly, let's just call it a day on that. Okay, so we're actually not going to do 23, just because that was time consuming. Okay, let's take a look at the next one. So this says, write the standard form equation, vertex form again, whose graph is a parabola with the indicated vertex, and it has to pass through the indicated points. So remember, we have y equals some coefficient a times x minus h squared plus k. This is standard form or vertex form of a parabola. And you have 4 of those variables to plug in. The only unknown is a. So for number 37, y is 14. We don't know a. X is negative 1. H is 1, so minus 1 squared, plus k, but k is negative 2, so minus 2. Then we do some math here. So I'm going to add 2 to this side. I get 16 equals, this is negative 2 squared, so 4 times a. A is 4. Once you find a, you have enough to go back and write in your equation. So y equals 4 times x minus 1 squared minus 2. So your final answer should only be plugging in h and k, and then the value you found for a. Number 40, same thing. I've labeled the vertex hk and the point xy. So here's my generic formula that I should be working with, standard form of a quadratic. Then I'm going to plug my numbers in. They're fractions. So negative 17 sixteenths equals a times x plus 1/4 squared minus 1. I'm going to add 1 to the other side. So if I add 16 over 16, I get negative 1 over 16 equals a. Oops, I forgot to put the x in. Sorry. X is 0. Equals a times 1/4 squared, 1/16. Okay, times 16 over 1. So this is negative 1 is equal to a. And then my equation is y equals negative x plus 1/4 squared minus 1. 57 and 58. Oh, I didn't leave really room to do these. Sorry about that. Let's see. So 57 says, oh, and the directions, I think I cut the directions off on this. Let me see. Do I have this book page? Sorry about that. Okay, yeah. 57 and 58 are up here, but the directions are down here. So let's get those on there. Maximize the product of two numbers. Find the two positive real numbers with the indicated sum whose product is a maximum. I'm going to try to squeeze this in up here. Okay, those are the directions for 57. So the sum of the first and twice the second is 24. So x plus 2y is 24. We're trying to maximize the product. The product between the two numbers would be like p equals x times y. And if I'm trying to find a maximum product, then I need to use substitution here. So this will be a quadratic once I get it in terms of x and y. So x can equal 24 minus 2y. And then I can sub this in and say, instead of p equals x times y, it's x times 24 minus 2y. So p is equal to 24x minus, oops, wait. Sorry, I subbed in for the wrong thing. Subbing out x, make that 24 minus 2y times y. There we go. So p will be 24y minus 2y squared. What would the maximum product be? It would be the max would be the vertex. So the vertex is opposite of b over 2 times a. Negative 24 divided by negative 4 is 6. Plug that in. 24 times 6 minus 2 times 36. Oh, that's a lot of work. What if I don't want to do all that math? 6 is the y coordinate that we just found here. X is equal to 24 minus 2 times y. So x is equal to 24 minus 12. And so the max product would be, the max product would be 12 times 6, which is 72. If I don't have a calculator, I don't feel like, I mean, I could do that math right there, but why bother with that when we can just say, oh, product is x times y, figure out y, figure out x, multiply them together. Let's see how 58 comes out. Sum of the first and 3 times the second. The sum of the first and 3 times the second is 42. Same idea. P equals x times y. So solve this equation for either x or y. It's easiest to solve it just for x to get it by itself. Replace the x with 42 minus 3y times y. So now my formula for the product is 42y minus 3y squared. I want the max product, so I'm going to find the vertex. So the vertex, the h, would be negative 42 over 2 times negative 3. Negative 42 divided by negative 6 is 7. And remember, that's the y coordinate because y is the input here. And then what is x equal to? Well, x is equal to 42 minus 3 times y. 42 minus 21 is 21. So the max product will be 21 times 7. 20 times 7 is 140 plus 7, so 147 is the max product. All right, now I kind of encroached upon part A here. So, okay, number 60. A child care center has 200 feet of fencing to enclose 2 adjacent rectangular safe play areas. See the figure here. Write the total area of the play area as a function of x. So there's fencing. There are 3 fencing sections that are y feet long, and then there are 1, 2, 3, 4 that are x. So my equation would be like 4x plus 3y equals 200 feet of fencing. But then we want an area function. So area would be the area of this whole thing is of this big rectangle. Ignore the line of fencing in the middle. It's 2x times y. They want it as a function of x. That means get rid of the y. So take this equation and solve it for y. So y would equal 200 minus 4x, whole thing divided by 3. So 2 times x times 200 minus 4x, all divided by 3. Now you can leave it like this. There's no reason that we have to FOIL this together, or not FOIL, distribute this together. You could if you want to, but you don't have to. So then use the table feature of the graphing utility to create a table showing the possible values of x and corresponding to the total area. Use the table to estimate the dimensions that will produce the maximum. Okay, now I left my work up here, but I will go ahead and do it with you. This is a little bit silly. I don't love when they ask us to make a table to do something, but just in case we would need to. Now, my function is like, I have it written as a of x equals 2x times fraction 200 minus 4x over 3. That's fine. I would use the graph if I'm using a graphing utility, but they want me to make a table, so I'm going to make a table. I need to think about what the domain is here. You can't have anything negative for x, so our domain should start at 0. So we have 0, a of 0. And then right here, I'm trying to think of like, where's the other 0? So 200 minus 4x would need to be greater than 0 as well, because you don't want to have a negative for that dimension. So if you solve that, you get 50. So the x values can only be between 0 and 50, but not exactly those to get fencing available. So I can zoom it here. That doesn't really help me like find the vertex, but the vertex would have to be, if those are the zeros, the vertex has to be in the exact center of the zeros. So if I type in 25, a of 25. Now I can zoom fit again and it will include that point for me. If you want to actually see the numbers in the table, see how I switched this? You'd have to type in a sub 1 down here and here and here for it to actually, and then type this in up here as a sub 1, a of x sub 1, I mean, and then it will calculate the values for you. But I think it's probably better just to use the graph. So that is my vertex. If I'm not sure, I could say, well, what's a of 24? And it plotted that for me, but see how that's not quite as high. So you can put as many values into the table as you want, but the maximum should be halfway between the two zeros if we're looking at a quadratic. All right, so I left my answers up here then. So for part B, it says use the table to estimate the dimensions that will give you the max area. So here's the max area. The dimension for x is 25. Remember, you can calculate y by doing 200 minus 4x over 3, and that comes out to 100 over 3 feet. And then part C was just graph, which I already did, and find the vertex that way. So same conclusion. Part D says write the area function in standard form to algebraically find the dimensions that will produce the maximum enclosed area. Now, we already have an a of x equation, but let's distribute it. So it was 2x times 200 minus 4x all over 3. If I distribute that through, I get 4. Oh, actually, no, wait. I don't need to do all of that. Sorry. I was going to actually, okay, sorry. Let me distribute this through. If I wouldn't have already found the vertex in the previous part, I would say, all right, this is 400x over 3 minus 8x squared over 3. That's a of x. And then I could do the vertex formula, or I could get the vertex from part B and C. It was 25, 1, 6, 6, 6, and 2/3, 0.6 repeating. So I could also just write the vertex formula like this. A of x is equal to, what's the a? It's negative 8/3. So distributing helped me a little bit. Times x minus 25 squared plus 1,666 and 2/3. You could change this to an improper fraction if you do 1,666 times 3 plus 2. I think you get 5,000 over 3, if I remember that correctly. All right, number 63. So you have a steel wire that's 100 inches long. Oops, I didn't write this down. Write a function for the rectangular area enclosed by the sign of the holder. So we have 100 inches of wire. We are wrapping it around. They gave you dimensions here. We're not putting wire around the bottom. So it should just be, it says a of x. So write a function for the area. We'll start with how much fencing you have. Or wire. You have 100, and that's equal to 2 times x minus 6. Plus. Oh, no, wait. They already gave me the dimensions. I don't have to figure all of that out. So the dimensions for the area are it's in this picture. 100 minus 2x times x minus 6. What about domain? Well, x minus 6 should stay greater than 0, so x has to stay greater than 6. 100 minus 2x has to stay greater than 0, so you're not getting negative areas. This works out to be x is less than 50 because you're dividing by negative 2. For part B, you can see I put my function in the table again and use the graph to help me with that vertex. Okay, last problem, number 65. For selected years from 1955 to 2016, the annual per capita consumption C of cigarettes can be modeled by this. So again, I typed in this model. I added a table with 5 and 66, C of 5, C of 66, and did zoom fit. Okay, so I'm going to go ahead and type all that in. So start this fresh here. So C of T equals negative negative 1.08 t squared plus 19.2 t plus 4,048. I like to zoom fit with the table here. So we're going from 5 to 66. C of 5, C of 66, zoom fit. What year, determine the year and approximate the maximum per capita consumption. So I'm going to get myself near the vertex here. There it is. And I can't see it very well. There we go. So this is coming out to 8.8 repeating. So let's see. All right, so I'm going to write this down. So let's see. 5 is 1955. So 8 would be like during 1958, max consumption was about 4133.333. We're labeling that in cigarettes. Let's see, annual per capita consumption. So cigarettes. I'm just going to write that down, I guess. Annual per capita consumption. The next part says, beginning in 1966, all cigarette packages were required by law to carry a health warning. Do you think the warning had any effect? So, yeah, 1966 or any time after the peak, which was at 1958, the graph is decreasing. So the consumption of cigarettes is decreasing and it's concave down. So you're decreasing at an even faster rate, like the slopes are getting steeper and steeper. So, yes, the cigarette consumption decreased.